All right, so if you were watching this online, then you would notice that the last half of the uh, slides when I was talking, the recording didn't work. So I lost all of that. So I'm going to quickly run through what I said in those last few minutes. Which is one, we have two different kinds of orbitals. We have hybrid orbitals and we have p orbitals, unhybridized p orbitals. And we use them in different ways. So hybrid orbitals are used for two different things. One, when they make sigma bonds. When you have a hybrid orbital on one atom overlapping with a hybrid orbital on another atom, it makes a sigma bond. Two, hybrid orbitals are used to hold lone pairs when they don't overlap with orbitals from any other atoms. All right, so those are the only two things when you identify the hybridization of an atom. The hybrid orbital should either be making sigma bonds or holding lone pairs. P orbitals have two potential jobs. One, when you have p orbitals on neighboring atoms that are parallel, they make pi bonds. And two, you'll see this later, when an atom has an incomplete octet, then there's an empty p orbital on that atom. That empty p orbital will become important later when we talk about how molecules will react with each other. But for now, you can kind of ignore that. You're not going to see examples of that yet. All right, so I wanted to do one example where we describe the bonding in a molecule. And there's not like a standard format for this. This isn't something where you have to worry, oh, am I saying this exactly the right way? But it's really about understanding what the bonding picture looks like in a molecule. We will get into more detail about the ramifications of the orbital overlap in this description when you do Module 10. But for now, I just want you to be able to look at the molecule and kind of break it down into, all right, here are the orbitals, here are how they're used. So I drew this molecule here. I drew in all the hydrogens. If you had a skeletal structure, you would have to draw in the hydrogens for yourself because you want to remember that they're there. What's the other thing that's not showing this picture that is actually present in the molecule? Lone pairs. So you're going to want to draw in your lone pairs in the molecule. So I've got 2 on oxygen, I've got 1 on nitrogen. All right. So then you probably want to assign hybridization to every non-hydrogen atom. So let's start we'll go from right to left. So we'll start with nitrogen. How many electron domains around nitrogen? 4. So this would be sp3 hybridized. This carbon in the middle here, 4 domains, so also sp3 hybridized. This carbon over here with a double bond to oxygen, 3, so that's going to be sp2 hybridized. And the oxygen, also 3 domains, so that's also going to be sp2 hybridized. All right, so now what we should be able to do is look at every pair of electrons represented in the picture and say, okay, what are the orbitals that pair of electrons is occupying? Or what orbitals, do the electrons occupy? So we can start on either end. Let's start with the double bond over here. All right. When I look at the CO double bond, first of all, what 2 kinds of bonds are there? Whenever you have a double bond, what bonds are there? Libby? A sigma and a pi. All right. So we have a sigma bond. What orbitals come together to make the sigma bond? An sp2 orbital from the oxygen and an sp2 orbital from the carbon. So one way to write that might be to say, all right, comes from oxygen sp2 and carbon sp2 orbitals. So that's where the sigma bond comes from. And then what does the pi bond come from? Pi bond comes from oxygen p orbital and carbon p orbital. All right, now on that oxygen, there are two lone pairs. What kind of orbitals are those occupying? Those are occupying the sp2 orbitals. So then the lone pairs on oxygen those lone pairs occupy sp2 hybrid orbitals. All right. Then this CH bond that I highlighted in orange here. What kind of bond is that CH bond? Sigma. So this is a sigma bond. And what two orbitals come together to make that? An s orbital from which atom? The hydrogen. With hydrogen, it only has an s orbital. So with hydrogen, the bonding is always boring. It's just one bond made from the s orbital. All right, so this comes from the hydrogen s orbital and the carbon sp2, because that carbon is sp2 hybridized. All right, notice now in our description, for the oxygen, we've described how 1, 2, 3, all three of its sp2 hybrid orbitals are used. We've described how its leftover p orbital is used to make the pi bond. For the carbon now, we've described how its p orbital is used to make the pi bond. We've described how two of its sp2 hybrid orbitals are used. What's the third sp2 hybrid orbital on this carbon atom doing? Making a bond to the other carbon. All right, so this green bond, now that green bond we could say is a CC sigma bond. What two orbitals make it? A carbon sp2 orbital and a carbon sp3 orbital. Because those two carbons have different hybridization. All right, so we can just continue on down the molecule. We have two more CH bonds, these ones that I'm highlighting in purple. Those CH sigma bonds are made from carbon sp3 orbitals plus hydrogen 1s orbitals. I'm running out of colors, but that's okay. This dark blue CN bond, I have a CN. What kind of bond? A CN sigma bond. And that's from what orbital on carbon plus what orbital on nitrogen? sp3 on both. Yep. All right, we've got the lone pair on nitrogen What kind of orbital does that live in? An sp3. And then we have the last two sigma bonds over there, those NH sigma bonds. And those would be from nitrogen sp3 orbitals and hydrogen 1s orbitals. So that's the description. The common mistakes I've been seeing is people saying lone pairs are in p orbitals, or saying that, you have an atom that's sp2 hybridized, and then you say that it's making a bond using an sp hybrid orbital, which it doesn't have because it's sp2 hybridized. So you should be able to go through and give that kind of systematic description for any molecule. And it gets tedious after a while, and that's good. Once it gets tedious, you know it, and you can stop practicing it. Are there questions about describing bonds in a molecule? All right. Beautiful.